DWGS is an international project supported by the 2020 Horizonte program of the European Committee, implemented by the GIZ in cooperation with 13 organizations with experience in 4 continents. The main goal is to establish a closer cooperation between technology European suppliers and biogas stakeholders in participating countries. The project works through different initiatives like a digital platform, seminar development, technical meetings and visits to plant in different countries. On the website you can access to different documents, dossiers and developed webinars.
Continuamos entonces con las visitas virtuales. En esta ocasión los invitamos a conocer dentro de la provincia de San Luis, una provincia central de Argentina, un caso emblemático en cuanto a economía circular, donde van a encontrar producción ganadera, producción agrícola, producción de etanol y una diversidad de fuentes de alimentación del digestor, generando energía térmica y energía eléctrica. Por lo tanto, cumpliendo todos los paradigmas que estamos promoviendo desde el proyecto. Por lo tanto, sin más, los invitamos a conocer en detalle la planta de Tigonbu.
The company Tigonbu was created in the 80s from the hands of a family with a tradition in agricultural activity, focused first on the province of Cordoba, later extending the productive horizon to neighboring San Luis. The third generation, which today drives the same process of agroindustrialization, began some time ago, which is reflected in a vertical integration with diversification of grain production, through conversion to meat, biofuels and more recently bioenergy, achieving a total added value at origin for the crops.
Al estar alejados del puerto, teníamos mucho costo de flete para llevar nuestra cosecha. Entonces, en un principio empezamos con un feedlot para agregar valor al maíz que teníamos y para hacer más eficiente el engorde de los animales. Y hace un par de años, cuando el maíz valía muy poco, nos costaba más caro el flete de llevar el maíz a puerto que cualquier otra cosa. Entonces de ahí fue que surgió la idea de hacer una planta de bioetanol. Cuando estábamos haciendo la planta de bioetanol, uno de los costos más altos que teníamos, más allá del maíz, era el gas. Entonces ahí se planteó la idea de hacer un biodigestor para poder producir el gas para abastecer la planta de bioetanol. De paso, para aprovechar el estiércol de los corrales y darle valor a eso. Cuando estábamos viendo presupuestos, viendo qué tecnología usar, viendo qué planta necesitábamos para abastecer todo lo que era la planta de bioetanol, surge que una empresa que tenía asignado 2 contratos del Renovar 2 decide no hacerlos. Entonces, bueno, nosotros tomamos esos 2 contratos y pedimos cambio de domicilio, cambio de tecnología, unificación de contratos, todo, que nos los dieron, y bueno, y de ahí surge esta planta de biogás de 2 mega, que tenemos un contrato con CAMESA a 20 años, y bueno, se transformó en una unidad mucho más grande de lo que en un principio se había pensado.
Thus, it became a mixed field with 8,000 hectares in total. Approximately 2,000 are used to chop corn for silage, which is used both in the fattening of bovines and for the generation of biogas, a unit that also takes advantage of waste from livestock activity.
Acá el maíz tiene dos vías, hacemos maíz picado, que se hace para la planta de biogás, y maíz picado para nuestro feedlot, y el otro camino que toma el maíz es maíz grano, que también se lo consume en el feedlot y en la planta de bioethanol con el que generamos bioethanol, ¿no?
The agricultural company of Buena Esperanza, San Luis, has a feedlot for 16,000 heads with a roof sector that has a concrete floor which allows to collect daily between 25 and 30 cubic meters of manure that are supplied to the digesters. However, the greatest contribution to biogas production is made by corn silage, of which about 100 tons are loaded daily. In total, between 125 and 130 tons of substrate are incorporated each day.
Esto nos lleva a una producción diaria de biogás de unos 26.000, 27.000 metros cúbicos de biogás que terminan en lo que es, dependiendo del consumo de los motores, de los generadores, tenemos una producción de 48, 50 megas de energía eléctrica, de potencia activa. La forma en que se produce este biogás consta de 4 digestores, 2 digestores primarios y 2 digestores secundarios. La mayor producción de este biogás la realizan los digestores primarios. Un 70% de lo que sería el potencial del picado lo aprovechamos en los digestores primarios. Los digestores secundarios están para terminar o tratar de aprovechar ese 30% restante de ese biogás que contiene el picado, aprovecharon los digestores secundarios.
This feed model of the digesters is in a process of change, since the light vinasse derived from the production of bioethanol plus the waste of the ration that is given to the animals will go replacing the maize silo as co-substrate, while the amount of manure collected will increase from the projected growth for the feedlot, since it is planned to build 11 additional sheds for the fattening of cattle for consumption.
Después tenemos como producción lo que sería energía térmica, la cual es producción de vapor para lo que sería la destilería que tenemos acá, la mini destilería, que se produce sin el uso de combustibles fósiles, sino con el uso de la energía térmica de los motores. Los gases de escape se aprovechan, pasan por una caldera, esa caldera evapora el agua y la enviamos directamente como vapor de agua a la destilería.
The digestate resulting from this process is also used for the production of biofertilizers. Through a series of separators, the solid fraction is divided from the liquid fraction. The liquid is set in a lagoon until it is spread in the field. Likewise, the solid matter is stored to be later spread in the crop plots. The maize silo is stored in the traditional cover bunker system. From there, special machines cut it and transfer it to the digester loading trays. Cleaning models are used for manure collection equipped with mechanical sweepers, which, by means of an electric motor and chains, run across the stable floors in sectors to which the cattle go to feed, and it is there where they generally go dropping. This material is conveyed to the receiving trays, from where it is sent by channels to a general container, equipped with agitators to avoid settlings. From there, another pump propels it towards the digester loading sector. The animals coexist with the cleaning system that moves at a very slow speed. Waste of animal feed formulated based on chopped, broken corn, vinasse and maize distillage, it is also collected to be used in the feed mixture of the digesters. The distillates or vinasse from the ethanol plant will form the future feed for the biogas plant, thus integrating both systems in a circular concept. The daily feeding of the digester then consists of a mixture of corn silage, manure and food waste. Manure makes it possible to regulate and stabilize gas production. Special sectors are used for system recharging, To fill them, mobile backhoes are used that cover the path between the storage places and the separation chamber. An electronic system alerts the operators when enough material has been covered to start the process. The 4 digesters, 2 primary and 2 secondary, have a capacity of 4,000 cubic meters each. They measure 8 meters high and have a diameter of 26 meters. Built on concrete base and walls, it's covered by 2 membranes. The first is responsible for retaining gas production and stays inflated. The upper membrane is inflated with air to protect the lower cover and the entire interior of the digester.
Aproximadamente por digestor tenemos una capacidad de almacenamiento de biogás de unos 6.000, 7.000 metros cúbicos. Esa capacidad de almacenamiento, si bien es limitada, porque no es la capacidad de almacenar el gas, sino de ir consumiéndolo diariamente. Ante una detención de la generación, no se puede almacenar por mucho tiempo, sino que hay que quemar el gas.
The main processes of the digesters are agitation and heating. The idea is to maintain a constant temperature in that environment to favor the production of gas, helping the bacteria that produce digestion. With the same purpose, agitation of all the solid material that enters the digester daily is promoted. That digestate that is stored in the primary digesters later passes to a secondary digester with the same idea, maintaining agitation and temperature to favor the environment of the bacteria. This heating action does not require fossil fuels but takes advantage of the heat of the engine coolant. To achieve an optimal transformation and a good production of biogas, a certain temperature is required inside the biodigesters, which must be supplied by external agents since the reactions do not generate heat. The selected temperature for operation is 45 degrees and that heat is supplied through external exchangers to the tanks. The heat conductor is the water that circulates between the heat exchangers that recover the energy contained in the exhaust gases, the engine cooling ducts, and the heating coils of the mass indigestion. The temperature is permanently controlled and the automotion and control systems allow stable graduation to be achieved inside all the tanks, independently of the temperature recorded by the environment. The system is completed by the help coming from the isolation of all the biodigesters to avoid energy losses. Once obtained, the biogas receives 3 different treatments, which are carried out jointly. As we know, in this form of biogas production, high percentages of hydrogen sulfide are generated, which is harmful to everything that is metallic, especially the steel used in motors and pipes. Therefore, it is sought to reduce it, and the best way is to make it react with oxygen through an injection of air so that it acts on the sulfur and thus cancels it, without losing methane content due to this action. Activated carbon filters are also used to process that gas with a lower amount of hydrogen sulfide, thus reaching the admissible limits of each generator, which are about 200 parts per million.
El otro tratamiento que también este proceso lleva mucho en la producción de biogás es la producción de agua. Acompañado al biogás viene vapor de agua. Obviamente, como ya se sabe, ingresar agua en un motor no es recomendable, ya sea en forma de vapor de agua. Es por esto que tenemos un secador. Este secador se encarga, ¿qué hace? El biogás viene de los digestores a unos 40-50 grados, el secador lo enfría de golpe, le baja la temperatura del biogás a unos 5 grados y de esa manera este vapor de agua condensa y eliminamos por día entre unos 1.500 y 2.000 litros de agua diariamente de estos 26.000, 27.000 metros cúbicos de biogás que producimos.
With these 3 treatments, the biogas is intended to reach the engines in the required conditions. The parameters that are measured are carbon dioxide, oxygen, sulfide, and methane. The gas analysis systems allow permanent testing of the inlet and outlet quality to avoid possible damage to the engines or the boiler. The plant is equipped with a special room where the different pipes that carry the material come together. They use pumps to drive all kinds of substrates. Pneumatic actuator valves and electric motors allow total control of biomass loading, unloading, circulation, and heated movements. The concept of the plant is of a modular type, which allows the exchange of content between all the fermentation tanks. This gives great plasticity and adaptability in the face of changes in the diet or failures in any of the fermentation tanks. The biodigesters are remotely monitored and operated through a general control room that receives all the information. From there, different actuators, pumps, motors, and mechanisms can be operated in order to achieve optimal feeding, maintaining temperature as well as all the parameters that make correct operation. The data is transmitted online to allow external remote supervision of the operation of the plant, wherever the person in charge is. There are digesters and post-digesters, filling register sensors, operating temperatures, valve position, and motor status. The plant has two internal combustion engines specially adapted for continuous operation with biogas. The Genbacher generators, with a capacity of 1067 kilowatts each, are located inside specially conditioned and insulated containers to reduce noise generation, as well as strong temperature fluctuations. Each engine has its own continuous maintenance plan, which guarantees optimal operation, prevents breakage or failures that could imply the interruption of electricity generation. The system has backup generators and boilers to maintain the temperature and operation of the critical electric motors that must continue to function. Since the biogas and bioethanol plants cannot stop due to power outages, there is an independent generator set for each transformation plant with a power of 250 HP. Due to the complexity, the number of electric motors, actuators, and controllers, the plant has large rooms where all the circuits come together, with individual monitors where the status of each sector can be checked independently of the computer screens in the control office. A sector of this room is dedicated to the energy billing company, CAMESA, where the equipment that permanently reports the operation and delivery of energy to the interconnected system is located. The digestate that comes out of the biodigesters is separated by two adjustable press screw systems by means of a set of weight that allow the quantity of extracted liquid to be adjusted. The liquid fraction accumulates in an uncovered and waterproofed lagoon, which has a total capacity of 14,000 cubic meters. The solid fraction is stored in a special tray for distribution. The liquid is extracted from the lagoon with special pumps, and a specific sector was built for the loading of digestate distributors on a concrete beach. These biofertilizers incorporate the glume that is produced in the splitting of the maize grain. This plant carries out continuous test and monitoring of the different batches where biofertilizer is applied, carrying out environmental measurements and the effects on the different crops.
Lo que estamos evaluando, estaremos haciendo una sustitución del 80% de las bases nitrogenadas de fertilizantes químicos, sobre todo en nitrógeno. Y estos suelos, por sus orígenes, son muy ricos en fósforo. por lo que los niveles todavía, como no tienen tantos años de agricultura, no han bajado por debajo de las 25 partes por millán. Así que la idea es regular y nivelar ese nivel de fósforo en ese nivel. Así que sí tenemos deficiencias de azufre, que los análisis que nos ha arrojado el Digestato tenemos buenas cantidades de azufre y algunos otros micronutrientes.
The plant has its own transformer sector to raise the voltage from 1,600 to 33,000 kVA. In order to minimize transmission losses, 2.2 megawatts are permanently delivered. All electrical management is remotely monitored by the commercial and distribution company CAMESA. Based on delivery reports, operation, output, etc., the company bills. The biodigesters have been built by a company specialized in concrete called Arinco. The electromechanical control phase is also of national origin, where engineering and components are provided by Porta and Tecnored, both from the province of Cordoba. Special pumps, agitators, grinders, motors and generators are imported. The agro-industrial complex Tigonbu in San Luis is connected with the bioethanol plant, which consumes 30 to 45 tons of maize per day. It generates between 15 and 18 liters of ethanol, 13 tons of wet maize distillage, and 70,000 liters of stillage. The bioethanol is dehydrated, reaching a quality of 99%, suitable for blending with gasoline that is cut in Argentina. The byproducts are used in the same field to feed the cattle and in the future biodigester. The integration between the ethanol and biogas plants is done. One of the keys to this complementation is given in the set of boilers that supply steam and heat, which are fed with preheated water coming from the heat recovery systems of the cogenerators. This allows a reduction of up to 40% in the consumption of gas used in the operation of the boilers. The main fuel is also being replaced, changing LPG for biogas. Thus, energetically, plants do not require any supply of external fossil origin. This virtuous circle of agriculture and livestock, which contribute to the generation of biogas and electricity, added to an alcohol distillery, achieves the maximum use of all resources, since thermal energy produces the steam that the latter requires, replacing the use of a fossil fuel only with the internal transformation of the derivatives of each process. And the biodigesters could even produce enough gas to power the engines, so that they can cover the electricity demand of the entire complex, since the distillery can return components that help the digesters work.
Tiene subproductos la destilería, que son la vinaza y la burlanda. Son productos de desecho que actualmente se utilizan en lo que es ganadería. La vinaza se le da de beber a los animales, la burlanda tal vez se mezcla con un poco de alimento o se vende a terceros. Pero una forma de cerrar el círculo, esta economía circular que tanto les comento, es que ese aporte de vinaza, ese aporte de burlanda venga a la planta de biogás, ya que la planta de biogás fue diseñada para recibir distintos sustratos de otras empresas cercanas a la zona, de que su fin de producción no es solo el picado de maíz y el estiércol, sino que nos podemos mover en la receta gracias a ese diseño que hoy tiene la planta.